Hello everyone, this is Giuseppe Maggiore and this is another tutorial on how to use Casanova in conjunction with Unity to build games. In this tutorial we start off with a slightly more complicated initial scene. We have our nice Bob here, and Bob has a list of checkpoints. C1, C2, C3 and C4. No, let's put the scene view. Yeah. So C1, C2, C3 and C4. Now our goal is to build a script that makes Bob walk along the patrol route defined by the checkpoints with the correct animations. Before we dive into the Casanova script though, let's see what we have. Attached to Bob we have Unity Bob, which is a mono behavior, which simply, well, this is actually quite simple C# code, which contains a character, a controller, an animation, all the standard Unity stuff. The list of checkpoints which are looked up from the scene, a velocity which may be set from the outside. We just ignore the Y component. It allows us to get the position. It allows us to set the current animation among the two Bob animations, idle and walk, which are the only two animations which are supported. When we set the animation, we call animation.crossfade, a Unity function that does a smooth blending between the animations, and basically that's it. So Bob, and of course we can create a Unity Bob, which is a function that just finds the Bob nodes in the hierarchy and returns the Unity Bob component. So we're talking about a very basic C# class that exposes the Bob entity and allows us to control its animation and control its directional movement. Let's move on to Casanova. So here is where we'll build our movement behavior. Now, first of all, let's define the Unity Bob here. And of course in create, we'll say Bob equals to Unity Bob.create. This looks up Bob in the scene, looks up the checkpoints, loads the animation and controller component, and so on. Now, the only two things we want to change are Bob.velocity and Bob.current animation. Let's iterate the checkpoints. The checkpoints stored inside Bob. So for C in Bob, the checkpoints do, and we return the new velocity and the new animation. Now we say, the velocity is going to be initial velocity. Well, the checkpoint minus Bob.position, which we need to normalize, and we multiply by 0.1 because, well, otherwise the velocity is too high. And we return velocity 0 as the new velocity and Bob animation dot idle. Now let's start with something simple. We wait for, no, 1 second is not enough. We wait for, say, 3 seconds. Okay, wait for 3 seconds. Then we zero the velocity. Oh, sorry, here we had to put the walk animation, of course, because if we start moving, we idle Bob, and we wait for 2 more seconds. When we're done with the for loop, we wait for 3 more seconds, and then we resume with all the checkpoints. Now, let's test this initial version. Of course, I'm going to wait until the compiler is done. Okay, so let's run this. Let's see what happens. So Bob starts walking for 3 seconds, then he idles for 2 seconds, goes towards the next checkpoint for 3 seconds. Okay, so this looks like it's working, but let's make it better. Instead of just waiting for 3 seconds, we suspend, or we wait until we have changed direction, we have changed side with respect to the original velocity. So when the dot product between the velocity and the difference vector between the checkpoint and the position is smaller or equal than 0, it means that we have shot past the checkpoint. So in this case we stop. Let's go back to Unity. Now the scripts are compiling again. And there we go. So, ooh. Wait a second. Okay, let's run this again. So, Bob starts, goes to the first checkpoint, doesn't stop until he reaches the checkpoint. Okay, then he idles for 2 seconds. Then he goes to the next checkpoint, doesn't stop until he reaches the next checkpoint, which is there. Okay, 2 more seconds of idling. Then third checkpoint, idle, 2 seconds. Final checkpoint, which is in the starting position, 2 seconds of idle plus 3 seconds of additional waiting, and then Bob starts again. All right, this is all there is when it comes to building a checkpoint system. Thanks a lot for listening, and until next time.